Good morning, everyone. Thank you for joining us. Excuse me, good afternoon, everyone. Thank you for joining us today for the Introduction to Solar, Thermal, and Photovoltaic Systems webinar. My name is Beth, and I'll be co-hosting today's webinar, which means I'll be monitoring the chat window, and I'll be conducting some polling at the end of the webinar. Today, we'll be covering highlights from our half-day seminar, Solar, Thermal, and Photovoltaic Systems. We hope that after today's webinar, you'll be able to understand some of the fundamentals of solar and help apply them at your facility to help you save energy and money. We also want to thank our sponsors today, the Energy Trust of Oregon and Northwest Energy Efficiency Alliance. Based on customer feedback, we know that they appreciate that we are aligned with these organizations to help eliminate any confusion regarding energy efficiency and renewables. Before I introduce the presenter today, I'd like to show you some tools you'll be using during the webinar. To the right of your screen, you'll see several windows. At the top is you will not see the participants window. You'll see the chat window, and you will see the polling window at the end of the webinar. If you have any questions during the webinar, you can submit them to me through chat, to me, the host, through chat, and the instructor will answer them at the end of the webinar. At the top left corner of your window, under the Quick Start tab, you'll see some tools, which I'm highlighting now. An arrow tool, a text tool, and a marker tool. The instructor will give you instructions on when to use these throughout the webinar to annotate. And now I'd like to introduce our speaker for today. Bruce Barney is an engineer with Portland General Electric. He's a solar energy expert at PGE since 2001. He's also a PV homeowner since 2006. And he's a member of the American Solar Energy Society and a board member of Solar Oregon. So Bruce is quite the expert, and without further ado, I will hand the webinar over to Bruce. One moment, Bruce.
Good morning, everybody, or good afternoon. Thank you for allowing us to share your lunch hour with you. What we're going to talk about today is a brief overview of solar energy basics. That will include both solar thermal, where we use the sun to generate heat, and solar electric, where we use it to generate electricity. In broad strokes, we're going to talk about the technology, the pieces, parts that make up these systems, how to evaluate a good site for solar energy, and look at costs, benefits, and the incentives that are out there for commercial applications. Let me start by saying that solar energy, let me start by asking a little bit about you. If you could take your tools and just let me know what kind of position you have in your company. This will help us kind of tailor what we talk about to who our audience is today. So you can see we've got facilities people, sustainability people, energy people, maintenance people, and finance. So just put a check next to where you fall. That would be helpful. Okay, it looks like we've got people involved in both energy and facilities and maintenance, so I'll try and talk on those topics, especially for you. Let's see, basic solar info. I wanted to make a point that solar energy is a great resource for everybody here on planet Earth. There's an awful lot of it out there. You can see that we've got some 20,000 times enough solar energy hitting the Earth every day compared to what we're using in terms of energy. So the trick we have to do is find a way to capture that energy, convert just a bit of it to useful energy, and then we won't have to burn any oil. So at some point down the far, far distant road, maybe that'll happen. I wanted to give you an overview of where the United States stands relative to other countries, in particular Europe. We are a little behind the times relative to Europe and, for example, Japan. You can see from this slide that Germany is producing about 3% of its total energy from solar. Here in the United States, we're down at less than 1%. The good news is we're still seeing tremendous growth in the United States here. I've got a slide later on that'll kind of show you, and it really is exponential growth that solar energy is seeing here in the United States. We hope that can continue in that trend. Moving on, we're going to start with solar thermal. So this is where the sun's energy is converted to heat energy and then used in a useful way for your commercial facility. We're going to talk about the pieces and parts, the technology that make up solar thermal systems, and of course go into costs, benefits, incentives, and a little bit about site evaluation. One of the nice things about solar energy is it's a great presentation to give because I can always use lots of good pictures. This one is actually of a solar thermal energy site. Quite a few panels. We can see, what, 10, 11, 12. There are probably 12 or more panels in this site. You can tell it's solar thermal because you can see the shape is basically a bunch of pipes. The water would come in the top probably, flow down the system, and go out a pipe on the bottom. So we'll get more into the technology of what particular type of panel this is, but I wanted to mention that. When you talk about solar thermal, you really have to start talking from systems of long ago because there's a lot of residual memory about problems that people used to have. Back in the 70s, Jimmy Carter was president, and we had a lot of incentives back then, just as we do today, and a lot of people put in solar thermal systems. Back then, the efficiency was pretty attractive, and the paybacks were attractive, so a lot of people jumped on the bandwagon when the incentives came out. Unfortunately, a lot of those systems were not very good systems. So a lot of people had a solar thermal system on their roof, and after a year or 2 or 3, they tore it off and gave up on solar thermal. We want to spend some time here today and say that that is not how systems operate today. Modern systems last a long time. They don't need a lot of maintenance. Efficiencies are very good. All of the controls and the technology and the valves and the pieces and parts used today are very reliable. So you can get a good payback in the right applications and build a system that lasts a long time. As back in the 70s, though, it's an incentive-driven business, and there are lots of incentives available to make it more reasonable to install solar thermal. We wanted to just give you a sense of the savings that are potentially out there. To put it into perspective that hopefully everybody can understand, a household, a residential application of solar thermal, if you install a typical 1 or 2 panel system on a house, you can save 50% of your energy cost for heating water by putting solar thermal in Oregon on the west side of the mountains. That's a pretty well documented number. The Energy Trust of Oregon uses that for a lot of their calculations. So you can pretty much say that half of your heating costs for water heating can be solved by solar thermal. So it basically becomes free once you install a system. Compared to solar electric systems, solar hot water collectors are very efficient at harvesting the sun's energy, more than 3 times as efficient. So you can get 50 to 60% of the solar heat that hits the solar collector into the water as useful BTUs or useful energy. I should mention here, this picture is another nice one that I like. This is a picture of the Lucky Labrador Brew Pub here in Portland. They installed, as you can see, a very big thermal system on their roof. They use a lot of hot water in their brewery process. And I think this guy is actually drinking a mug of beer, a pint of beer that was brewed with sunshine. They actually, when they put this system in, created a beer that was named something like Sunshine Beer. So they're very happy with their system. They actually have systems on both of their locations here in Portland. It works very well for them. We wanted to ask a little bit about how important your facility's hot water energy costs are to your particular company. This will give us a sense of how we should concentrate on solar thermal or not. And also a point I want to make is that, as you saw from that example about residential water heating, even if your hot water loads are almost insignificant, you can still invest in solar thermal and get a benefit for your system, for your company. So for example, if all you have is restrooms, you can put a little solar thermal system on your roof and you can take care of all your hot water heat for your sinks and your lavatories in your restrooms. So don't feel like you have to have a big load to make solar thermal work for you. I'll talk a little bit later about the PR benefits of having solar on your roof. This is a great way you can say, well, I don't really have a solar thermal load of any significance, but I want to show my customers that I'm interested in solar and that my company is green. You can go ahead and put a little system on your roof, supply hot water for your lavatories, save some ongoing energy costs, and everybody's a winner. So it looks like we've got a pretty good range of solar hot water use, of hot water use for your company. A couple people that have very critical loads, a couple that don't really matter, and some people in the middle. We wanted to give you a sense of the significance of solar thermal effectiveness in Oregon relative to some very good solar thermal applications in California and Nevada. Here you can see in Salem, we can still get a quite significant annual energy savings in the 2,200 range, whereas LA and Reno are a little above 3,000. So we can be very significant here. You shouldn't shy away from solar thermal thinking that we don't have a good solar resource here in Oregon. One of the common misconceptions about solar energy is that Oregon is too rainy for solar to work. If you start looking at how good a resource we have here and compare that to some other areas of the globe, for example, Germany, we actually have a better solar resource than Germany. So again, solar works in Oregon, even on the west side of the mountains. Portland is better than Germany, so there's no reason we shouldn't be investing in solar energy. Let's talk about the technology or the pieces and parts that are used in solar thermal systems. Basically, all the various systems use water as a working fluid to move the heat around. If there's any danger of freezing, the water is typically mixed with antifreeze to make sure there's no damage to pipes from expansion due to freezing. But bottom line, it's a water-based system. Most modern systems will incorporate active elements, in other words, pumps, valves that move back and forth automatically, things that are powered by motors, a lot of temperature sensors and controls to manage the system. There are passive systems that utilize just the difference in the density of hot water versus cold water to circulate water without pumps, but those are pretty rare. So in general, all your systems these days will be an active system. Now the thermal collectors all expose the water to the sun, but they do that in different ways. Basically, I wanted to show you a typical piping schematic for the water and show you how it works and some of the benefits of this typical schematic. Basically, the point of using solar thermal to heat water is that incoming water temperature is very cold. So your cold water supply is typically in the range of 40 to 50 degrees Fahrenheit. You typically use water at 110, 120, sometimes 130 degrees Fahrenheit. To get the water from that cold incoming temperature to your desired outlet temperature takes a lot of energy. If you can preheat the water in a preheater tank with your solar collector, all the energy that comes out of the solar collector can go into that water. Basically, it can do that because the temperature difference between what comes out of the solar collector and what goes into the solar collector is pretty big. So for example, on a summer day, even if it's cloudy, if the outside temperature is 70 degrees, you might have 50-degree water coming into the collector. The collector itself might only be able to put out 80-degree water, but now instead of having 50-degree water come into your water heater, you've got 80-degree water coming into your water heater so that you save a lot of energy. You only have to bring that temperature from 80 degrees up to 110 instead of from 50 degrees up to 110. So that's exactly half of your energy, even on a cloudy summer day, is coming from solar collector. So the other big advantage of this schematic is that your regular water heater stays in place. It's sized to meet all your hot water needs in the absence of any sun. So that, for example, if you're a house, a lot of kids come home in the dark and shower, you still won't run out of water because the main water heater, the fuel-fired hot water heater, is going to be there to provide all the hot water you need. So the solar system just offsets your existing hot water heater when there is heat available. Okay, there are two main types of solar collectors. The first one I'm going to talk about is what we call flat plate collectors. These are pretty easy to understand. They're basically a box that has pipes in the back of it that are painted black. The sunlight comes in, goes through some glazing, typically glass, and into the box where the pipes are exposed to the sun. The pipes heat up. The glazing keeps the temperature warm inside so that energy that is in the black pipes now doesn't escape back out again. And then the water goes down through the pipes and goes into the collector. Goes into the storage tank or wherever you're going to use the hot water. So that's the theory behind the flat plate collector. These collectors are the least expensive collector that you can buy. They're pretty much very robust. There are no moving parts. They're very easy to build. They last a long time. They are the least costly of the collectors, but they are also the least efficient. As usual, the old saying holds, you get what you pay for. Now, the second type of collector is what we call evacuated tubes. For just that reason, again, like that picture of the evacuated tubes in the beginning, these collectors are made up of a bunch of tubes running across the collector. Each tube has its own pipe inside it with a clear glass, typically outside layer. The sunlight comes in, goes through the glass, hits the pipe, concentrates the heat into the pipe. The beauty of these systems is the sun's energy can go through the vacuum, warm the water, but it can't get back out because the energy has a hard time going through the vacuum when it's in the form of heat. It has an easy time going through the vacuum when it's in the form of sunlight. These collectors are very efficient, but they're a little more costly than flat plate collectors. Wanted to talk briefly about sites and what makes a good site. When you think about solar thermal, there are two things to consider when you look at your site. One is what your load is, or how much hot water you're going to need. In addition to how much, you need to think about when. So the when aspect of it will determine how much storage capacity you need for your hot water. One of the nice things about hot water systems are that you can store the solar energy. Unlike when you have solar electric panels, it's pretty hard to store that electrical energy. With solar thermal, all you need to do is put in a water storage tank and you can store that solar thermal energy. Good examples of loads that work real well for commercial applications for solar thermal are laundries, breweries, et cetera, et cetera. So basically, people who have a pretty big load, it works great if your load profile is synchronized with your solar insolation. In other words, when the sun's out is when you use the hot water. So a laundry that only works during the day is a great application. A industrial user of hot water that has 3 shifts that all use a lot of hot water, a little less cost effective because you're going to have to add some storage. And then relative to the solar exposure, you want to have good solar exposure during the prime solar hours of the day. That's typically from around 9 in the morning to 3 in the afternoon. If you have shadows on your site, say from 6 a.m. to 8:30 a.m., that's not going to make a big impact on how much solar energy you can harvest because most of your energy is going to hit from 9 a.m. to 3 p.m. Another common misconception is that your solar panels should face due south. That's true for optimization, but if you don't have a true south exposure, it's easy to make a case for, say, south-southwest or south-southeast. If you vary from directly due south by up to 45 degrees, you won't take a big hit on your solar harvest because you get most of the energy that way, even though you're a little off due south. So don't get concerned if you have to orient the panels a little bit off of due south. Lastly, I need to mention that there are structural concerns when you start putting solar thermal panels on your roof. You have to be considerate of the weight of these panels. With the water in the panels, they can get fairly heavy on a loading per square foot or pounds per square foot basis. We've found that a lot of recent construction has a fairly tight tolerance for loading. In other words, when they built the building, they built it just to code and didn't use anything beefier than they have to for roof support. So you'll need to get your structural engineer involved at some point to validate, verify that your roof has the capacity to hold these panels up. Okay, let's talk about costs. Again, for perspective, let me talk about residential size. So here in Oregon, a household residential unit, typically 1 or 2 panels on the roof. Of course, commercial panels can scale up from there, but a typical household system will have a first cost before incentives of somewhere in the range of $5,000 to $8,000. You can, of course, scale that up for commercial to any scale you need, but you can say, well, if I only need to do a lavatory, maybe I can get by with a $3,000 system. That'll hopefully give you a perspective on costs. One of the nice things about solar, both solar thermal and solar electric, is that it's pretty easy to scale the systems up or down. You can add panels, change the size of pumps and tanks, so you can meet whatever your load needs or whatever portion of the load you can afford to meet with solar thermal or solar electric. Let's talk about incentives. Right now, we have seen incentives come down from what they were, but fundamentally, you have 2 basic mechanisms for solar thermal incentives. You've got the Energy Trust of Oregon. I should mention that the Energy Trust incentive is only available to you if you are in a territory that's served by one of the utilities that helps fund the Energy Trust. So that's one of the big questions you'll have to answer if you start to look into these projects. You have a variable incentive from the Energy Trust based upon whether your fuel that you're using now is electricity or gas. And the incentive will vary as well with what company serves you for that electricity or gas. Typically, we see Energy Trust incentives in the range of 10 to 15% of the project first cost or total cost. So Energy Trust is one of the first incentive categories we need to talk about. The next one is federal tax incentives. There is a 30% tax credit, so that comes right off your taxes due. That tax credit is 30% of eligible costs, so please be aware that it's not the first cost, it's the cost that's eligible for the tax credit. Basically, that means you have to subtract your Energy Trust incentive from your total cost before you calculate your federal tax credit. In addition to the federal tax credit, you're eligible for a tax treatment on your investment to get a modified accelerated cost recovery of that. Your accountant can tell you more about that, but we usually see that that benefit pencils out to somewhere around 10% of the cost. And lastly, there are some special property tax treatments that you're eligible for, so you can save some money on your investment with a reduced property tax. Let's talk about solar electric now. This is a very different animal than solar thermal, but fundamentally shares some characteristics of solar thermal, such as what makes a good site. Some of the costs and benefits are very similar. The incentive treatment is very similar as well. And let's start off talking about the technology, the pieces and parts. First, let me give you some idea of some important vocabulary that you'll hear as you pursue solar PV. These are words you've probably heard before for the most part, but I wanted to give you a little bit of information about what they mean. First off, when you look up at a roof or you see a big bunch of solar panels, PV that is, on a field, what you're looking at is called an array. So that's the whole system of solar panels. An array consists of multiple panels that are wired together to produce strings of panels. So the lowest sized device that we'll talk about is what is a panel. A single panel typically might be, in this day, rated for 275 watts of production. Those single panels are wired up into strings, and then the strings are wired up into the array output. The strings are wired up in what we call a combiner box, which is basically an electrical junction box. And then the array output is wired to an inverter. The inverter is the thing that actually does something. It has devices in there that convert the direct current that comes out of the panels into alternating current that can be connected directly to the grid. So those are some terms that you'll hear as you move forward into looking at a solar PV system. Let's talk about the panels themselves. PV panels are a device that have been around for a long time. For you folks in maintenance and facilities, the warranty on panels is typically now 20 years or more. There is a degradation percentage built into that warranty, but fundamentally your system, you should plan on it being active and running for at least 20 years. There's been a lot of history on some of the very first panels built, and one of the reasons that we don't know how long we can say these things last is because they're still up and operating, even though some of them were built in the 60s and 70s. So they last a very long time. There are three main types of panels: monocrystalline, polycrystalline, and thin film. The first two names get their derivation from the construction of the silicon that's used to make them. Monocrystalline is actually called monocrystalline because it's built from one big crystal. The panel on the right is an example of monocrystalline. The little empty spaces in between the little chips, if you will, or the little pieces of silicon are because these pieces came from circular cylinders that were sliced to make the wafers. So you can, at a glance, say this is a monocrystalline just because it has those openings between each four sub-chips that are in the panel. A polycrystalline, this is an example of polycrystalline panels. The reason they call them polycrystalline is that each little wafer is made up of lots of different crystal orientations. That makes it look very different than the monocrystalline. I would liken the look of this to an ice cube. When you look at an ice cube, you can see all kinds of different lines and striations in the cube. Basically, what they do with polycrystalline is freeze the silicon in place and then slice it up. When they do that, they will freeze it in a cubical form. When they slice it up, it makes squares, so you don't see any openings or voids in the panel between the various wafers. So at a glance, you can tell polycrystalline. Now, monocrystalline have the best efficiency in the high teens, so we're seeing panels that can be as high as 19 on the commercial market right now, 19% of the energy that hits the panel from the sun will be converted to electricity. Polycrystalline is a little less, more like 15%. Because the monocrystalline gets the best efficiency, it also costs more to make, and it costs more to buy. So you can work with your contractor to see what makes the most sense in terms of what type of panel you want to buy. The last panel I'll talk about is very different than the first two. Thin film panels are made with an entirely different process. You can think of thin film panels as being printing. So you put the substrate through a printer and it prints the photovoltaic material onto a substrate. That makes it very inexpensive to make, but inherently the efficiency is not as good. So you can say that the efficiency of this product is about half of what polycrystalline or monocrystalline would be. That should tell you that you might need twice as much of it to get the same output as the polycrystalline or the monocrystalline. The times when you'd use thin film are typically where you're not constrained by size. So if you have a huge warehouse roof and you don't need a big system, you might say the best thing for your application would be a thin film system because you have lots of roof space to cover with panels. The other thing about thin film that is a big advantage is that it tends to be lighter than polycrystalline or monocrystalline. You can get thin film that doesn't even have aluminum frames on it, doesn't have glass covering it, so you can save a lot of weight. Again, going back to those recent buildings that have a very tight tolerance on their code requirements for structure, you might find that you can put thin film panels on your roof when you actually don't have enough capacity or strength in your building to put polycrystalline or monocrystalline on the roof. So that's another time when thin film would be a good solution. I wanted to mention here about panel ratings. Panels are rated in watts of output. That represents how much energy at standard test conditions the panel will produce. Standard test conditions, they actually expose the panel to an artificial sun source and measure how much power comes out. That's the STC rating. To put the rating into perspective, in Oregon here on the west side of the mountains, you might expect to see the panels actually perform at their STC rating, but it'll probably only happen at the height of the noontime sun in the summertime when the sun is very strong here. So in the wintertime, for example, even on a sunny day, the output of the system will not be what your standard test condition output indicates. It'll be something less. Okay, let's move to the next slide. The last piece and part I wanted to talk to you about for photovoltaic systems is the inverter. Again, as I mentioned, you can scale up or down these systems. The inverter can be very large or very small based upon what your system size is. Typically, we see people use one inverter for a given array. That's because it's just more cost effective that way. That really holds pretty much true unless you start getting a system that's so big that you can't get a single inverter to handle that amount, or your system is spread out over such a big geography that you don't want to run a lot of wires around, so you say, well, I'll put in 4 inverters instead of just one big one. I should mention here this term, microinverters. There is a technology out there that uses lots and lots and lots of small inverters. Basically, you take an inverter and match each panel up to its own inverter. That means that on the back of each panel, you're producing AC power, so that when you wire these panels together, you're wiring AC power instead of DC power the way you would with a regular inverter. The microinverters have some advantages, particularly on small systems, particularly on systems where your solar site might have some shadow concerns. Microinverters work very effectively on systems that have some shadowing. So work with your solar contractor and see if microinverters might work for you. Typically, on larger arrays, microinverters get so expensive that it forces you to use a big inverter rather than microinverters. This gives you a plot of recent solar growth in Oregon. These are commercial solar installations. You can see the trend here. It basically looks exponential. We're seeing that continue in 2012, at least so far. So I wanted to show this to you just so you got a sense that even though incentives may be coming down, we're still seeing a lot of people do solar. Now, I've talked with a lot of people over the years and found that these rules of thumb are very helpful. So I wanted to go through these with you. They'll give you a ballpark idea of how big a system is, how much it might cost, and what the economic benefit of that is, or in other words, how much electricity will it produce. Now, as you can imagine, a solar system on a roof on a nice sunny day in June is going to produce a lot more electricity over the course of that day than it would on a nice cloudy day in January. So in solar PV systems, we know pretty much what the solar insolation is, or how much solar energy is coming in, and we can forecast that very accurately on a year's basis. We may not know what will happen tomorrow. We may not know how good a month this month will be, but on average we can say over the course of a year that sunshine will generate so much power if you have a 1 kilowatt system on your roof. So I've used a 1 kilowatt system as a building block here, make it easy to multiply out. If you have a 3 kilowatt system, just multiply all these numbers by 3. But basically a 1 kilowatt system, now that means that the panels are rated at 1,000 watts. So you may have, for example, 4 250 watt panels that are combined into an array that's 1 kilowatt worth of PV, or 1,000 watts of PV. That's going to generate 1,000 kilowatt hours over the course of a year. So those great days in the summer plus those not so great days in the winter, you add up all the output over the course of a year, that 1 kilowatt array is going to produce about 1,000 kilowatt hours. Now, a kilowatt hour is what you and I pay for every month when we pay our electric bill. Kilowatt hour is what has a value to you. It's what impacts your pocketbook. Here in the Portland area, I usually use 10 cents per kilowatt hour as the retail value of electricity. So you can see that a 1 kilowatt system producing 1,000 kilowatt hours per year, that's going to have a benefit to your pocketbook of about $100. So I hope that gives you a little perspective on how much money the output of these systems is worth. You need to have a very big system to make the financial benefit be attractive in itself on output. So that's why we see solar PV incentives, is to help you make sense of buying a solar system. Now, the next rule of thumb I'd like to talk about is how big these systems are. That same 1 kilowatt system will take up about 100 square feet of roof. Now, this is based on crystalline panels. Thin film would be roughly twice that much. So to put it a different way, an area of about 10 foot by 10 foot on your roof would give you a 1 kilowatt system. If you're interested in a 10 kilowatt system, you're going to need about 1,000 square feet. So that's how this rule works. Now the last one I want to talk about is, in a way, the most scary, because this puts dollar signs on that 1 kilowatt system. That same 1 kilowatt system we've been talking about will cost, first cost, out-of-pocket cost, $3,500 to $5,000. Again, it's very scalable. 10 kilowatt system, $35,000 to $50,000. That may sound like a lot of money based on the output you're going to get out of this, but the incentives are a lot of money as well. We wanted to ask you if you could tell us a little bit about your customers and their interest in being green or renewable energy. The driver for this question is to talk to you about the PR benefits of having solar energy on your roof or in front of your building. It's a hard thing to quantify, but we've found lots of commercial segments of our business really enjoy PR benefits from having solar. A good example is the winery business here in Oregon. A lot of wineries have found that putting solar panels up in their field of, in their vineyard is a very good thing. It attracts a lot of people, a lot of interest, and they've found ways to make it cost effective. One of those benefits that they use to make it cost effective is to quantify the PR benefit of having solar on their property. So we wanted to highlight that here. It looks like some of you have some minor interest in having your customers consider renewables. I should tell you here that in Portland General Electric's territory, our customers as a whole are very interested in renewable generation. A good benchmark of that is the fact that PGE has more green power customers than any other utility in the country. When I say green power customers, I mean our customers pay extra to get that green power. Excuse me, I skipped one there. Let's talk about PV costs and benefits. We've already mentioned the cost range based on that rule of thumb of $3,500 to $5,000 per kilowatt. Some impacts to that total cost are site factors, what type of panel you're going to use and how you're going to mount it. Some mountings are more labor intensive than others. The system size, naturally, the bigger the system, the more cost effective on a kilowatt basis your system will be, just from economic impacts of the size of the system. Permitting costs, that's generally a fixed cost, so if you distribute that fixed cost over a bigger system, that'll make your installed cost per watt lower. Panel type, again, that may impact your mounting costs. It will definitely impact your panel cost. So all those things join together to determine where on this range you will fall. Site requirements are very similar to the site requirements for solar thermal. You want to get a lot of sun in the middle of the day, face generally south. You need to be concerned about structural support for the panels if you're putting them on a roof. Even if you're mounting them on the ground, how you mount them is pretty important. There are a lot of commercial systems out there for ground mounting. You shouldn't discount ground mounting if you have some area that's got a good site. I'll mention this one because it's one that most people wouldn't think of, at least at first, roof life. The incentive organizations all want to have a system that lasts a long time, and they want to see that your roof will not need to be disturbed for a long time. The concern there is that if you have to re-roof your system and you have to remove it to put that new roof on, you may not have enough money 5 years down the road to put the system back on. So that's the concern there. You, of course, want to have space for both the array and the inverter and the wiring in between the two. You don't want to have big distances if you can avoid it, because that makes the wiring more expensive. You want to have a connection to the utility to be nearby, and you want to make sure the interconnection is approved by the utility. It's best to talk to the utility as early in the process as you can to find out what's going to be involved with those interconnection expenses, and also to finalize the business arrangement with the utility. The bottom line is that you're connecting your generation to the utility's grid, and you have to deal with making that interconnection safe. That's what this interconnection is about. And you also have to deal with the economics of who pays for that energy, how much do they pay for it, what happens if you produce more energy than you use. All those questions are dealt with in the business arrangement that you have with the utility. Let's talk about the incentives. The incentives can be quite large. Fundamentally, you have state incentives and federal incentives. The state incentives are one of two types. You choose an either-or situation here. You can't choose them both. The state incentives, the first one I'm going to talk about is the Energy Trust of Oregon. That incentive varies, again, with the utility that serves you. It varies with sizing. There are lots of variables involved there, so you want to have your contractor work with the Energy Trust to figure out what the incentive will be there. The other state incentive option is you can go with what's called a feed-in tariff. This is a different way to incentivize you. The feed-in tariff is what we call a production-based tariff, and it pays you based on how much power you produce. It pays you a premium on that power. So for example, I mentioned 10 cents a kilowatt hour. The incentive in the feed-in tariff might be to pay you 30 or 40 cents a kilowatt hour for the energy you produce from your solar system. That contrasts with a capacity-based system where the Energy Trust under this option will pay you per installed watt, not per kilowatt hour that you produce, but per watt that you install. Lastly, the federal incentives. This again is a tax credit of 30% of your project cost. After you reduce your cost by grants, the Energy Trust incentive is considered a grant. You also get the MACRs from the federal government on your taxes. So those are the incentives for PV. Let me ask quickly if you think your business would be interested in or most interested in a combined solar project with both solar thermal and PV, or just a PV system, or for example a small thermal system that would offset just some heating loads in your building. And we threw a few hopefully funny ones in there as well. If you could go through and let us know that, that would help us understand a little bit about what your interests might be. We've got a couple people saying small thermal system. That's great. Solar thermal systems are by far the most cost-effective long-term investment you can make with solar. One of the reasons they're so cost-effective is they work so well, they're so efficient. That in turn actually impacts the incentives, and that explains why the incentives are less for solar thermal than solar PV. I wanted to talk to you about a few gotchas that are out there relative to Energy Trust dollars. We've had some experience where customers get into trouble where they might not be aware of these gotchas, so I wanted to mention that. First off, you must use an approved solar contractor to do the contracting work. Fundamentally, the Energy Trust is spending your money and my money and everybody else's money, in other words, public money, to incentivize these systems. They want to make sure that public money is spent wisely, so they want to make sure they're installed correctly, installed with a high level of longevity. To do that, they say you must use one of their approved contractors that's been trained to do good installations. You can find the approved contractor list on their website, energytrust.org. It's easy to find a contractor in your area. You can, as with most contractors, call up a bunch of them, have them come out and talk to you, do your due diligence to find a good contractor, check Better Business Bureau, for example, check the licensing board for contractors, make sure they have a good record there. You must have a good site. Again, they don't want to incentivize on systems that aren't going to produce a good return. You must have a good roof. Again, they don't want to have systems have to be ripped up and potentially not reinstalled in the near future. For PV, you must be in PGE or Pacific Core PP&L territory. That's because those customers of those utilities pay for the energy trust. So they don't want to incentivize unless it's in PGE or PP&L territory. I should mention there's a small slice of Oregon that uses Idaho Power, and if you're in Idaho Power territory, you're eligible for Energy Trust funds as well. I actually wrote it down twice here because it's so important. You must work with the Energy Trust before you start construction of your project. They need to approve the project before you start construction. That's very important. And similarly, if you're going to use the feed-in tariff route for an incentive, you're not eligible for Energy Trust and vice versa. Again, it's an either-or situation. Here's the Energy Trust website. It's a great website. I highlighted it here as well. It offers you a great overall view of benefits, incentives, and technology. This link here at Home Power is a great one. Home Power is actually a magazine, and their website has a lot of great information. Lastly, I'd be remiss if I didn't mention our Portland General website. We've got a lot of great information out there, and we also show you the forms and talk about the business side and interconnection issues there. Wanted to give you a sense of where to go next. Basically, you want to think about a high-level feasibility study. Go out and take a look at your roof. Think about where the shadows are. Think about where your loads are, your electrical connections. If it all looks good in terms of a good site, I'd recommend you start calling approved solar contractors. Generally, I think they're more than happy to come out and talk to potential customers. And that's it. Basically, the contractors are very sophisticated at making it painless for you. So you should be able to just sign a contract and go solar for your business. Thank you very much for participating in the webinar. I hope it's been productive for you. And feel free to ask some questions. We've got some time now to answer them. Beth?
Thank you, Bruce. I just put up a slide here of some future seminars and webinars that we have. And before we proceed to the question and answer portion of the webinar, I wanted to let you know that within a few days, we'll send you a follow-up email with a recording of the session and the PDF of the materials. I'd like to draw everyone's attention to a polling survey that I just opened up on the right side of your screen. We'd appreciate it if you could take the time to fill out the survey as we use your feedback to improve future webinars. So thank you very much for that. And now to the first question for Bruce. Bruce, how does the economics compare between solar installations on a flat roof and or a slant roof?
Well, that's an interesting question. I'd say that it's hard to make that comparison because there are so many variables. In fact, the variables probably don't have much to do with the slope or the slant of the roof as compared to what the roof material is. The driver for the costs of putting systems on the roof are how you anchor the system, how you seal any penetrations. So those are the kind of costs that impact the system cost, and those are dependent more on what the roof material is. Typically on a sloped roof, you use racking that's parallel to the roof and standing off the roof just a few inches. That is a pretty cost-effective racking system. If your slopes are steep, of course, you may have to tilt your panels that are pitched different than the roof pitch. If the pitch is very, very slight, you may have to, again, tilt the panels to their optimum angle. I'll throw out a couple ideas on flat roofs. Flat roofs are nice in one respect. You can use, if your roof structure is good enough, a ballasted system where you use weights to hold the roof, or excuse me, to hold the solar system down. That works particularly well because you don't have to have any penetrations through your roof to anchor the system to it. Of course, no penetrations means no leaks. As good as roofing material and roofing technologies are, I always get a little concerned when I see a lot of penetrations from a solar system. Just statistically, if you have 1,000 penetrations, there's a good chance one of them is going to leak at some point. So I always try to minimize my roof penetrations. I'd encourage you to do that. So in summary, it's more dependent on the roof material than the roof angle. The roof structure, of course, is a big determinant as well, how many anchor points you have to have, things like that. So I hope that answered your question, even though it wasn't exactly what you asked.
Thank you, Bruce. And our next question is rather forward-thinking. Do you have any ideas when we will have windows which generate electricity from their glass versus the solar panel that we know today?
Great question. I've often said that as soon as solar becomes more cost-effective than regular utility power, all of a sudden, everybody who builds is going to say, give me solar panels. And I still think that's going to happen, and I still think that's going to be true. As soon as solar windows or solar glazing gets to the point where it makes more sense to put a solar window in than another kind of window, and the paybacks all work out, everybody's going to say, hey, south side of the building, give me solar windows. The problems that we're seeing right now with that is that a solar window that you can buy today has problems on both sides of the fence, if you will. It doesn't make a great window, and it doesn't make a great solar panel. So you have to compromise. There are a lot of people that are using solar glazing in a compromise role. For example, down at the University of Oregon, I believe, there's a building that has some shading used on a wall that has a lot of glazing. So they didn't expect to have a great window there. They wanted to block some light. They used the solar panel part of that window to block the light. And yes, they take advantage of that blocking by making it a solar panel. That's a great application. To date, any solar glazing that we see is driven largely by the architectural needs of the site. In other words, the architect likes the look. It doesn't make much sense from a cost-effectiveness payback. I expect that at some point it will become cost-effective. I don't know when that'll be, but if I had to guess, I'd say 10 years plus.
Great. We have time for one more question, and I'll just ask a follow-up to the earlier question regarding the slope or flat roof. And that is whether or not a flat roof installation generates more or less power compared to a sloped roof installation, and why?
Okay, well, that's an interesting question. Again, I'll kind of dodge the bullet there. It's not so much what the roof pitch or roof slope is as what the pitch or slope of the panels is. The optimum angle for a panel is somewhere around, give or take, 45 degrees from horizontal. So right at the midpoint between perfectly horizontal and perfectly vertical is where the sweet spot is for orientation. If you have panels on a flat roof, typically you will mount them at an angle. So the racking system will pitch those panels at that optimum angle. If you're on a sloped roof and it's a 45-degree angle roof, you're there already. You can mount them flat. So I guess what I'd say is on a flat roof, you can typically easily mount the panels at the optimum angle. If you take the same panel on a pitched roof, generally we don't see pitches that are 45-degree angles, and generally it makes the most sense to mount that panel at the same angle as the roof. So generally I would say on a pitched roof, you're not going to be at the optimal angle. So I hope that makes sense, but the bottom line is generally speaking, you can make the panels work best on a flat roof as compared to a pitched roof.
Well, thank you, Bruce. That was the last question we have time for. We will, any other questions that have not yet been answered, we'll send out with answers along with the PDF of slides and the recording of the webinar. So I want to thank you all again for attending and thank Bruce, and we'll stay online for a little bit in case you have any additional questions, but thank you again.